Good morning and welcome to the next stop on our virtual tour. I'm Joel DeYoung, Extension Field Agronomist in Northwest Iowa, also here at the Northwest Research Farm to introduce some of the research that goes on at this farm along with across the state and our speaker for today. Dr. Matt Helmers is an Ag and Biosystems Engineering professor at Iowa State, also the director of the Iowa Nutrient Center. We really are grateful that you're here today, and we certainly look forward to the time when we can see you face to face again. Now, here's Matt Helmers.
Hello, I'm Matt Helmers with Iowa State University Extension and Outreach. I'm also a faculty member in the Department of Agricultural and Biosystems Engineering and director of the Iowa Nutrient Research Center. Today we're going to talk about some of the water quality monitoring and research going on ISU research and demonstration farms. Specifically, we're going to talk about work at the Northwest Research Farm near Sutherland, the Northeast Research Farm near Nashua, the Southeast Research Farm near Crawfordsville, the McNay Farm near Sheridan, and the Armstrong Farm near Lewis. Look forward to talking with you about this work today. First off, we're going to start in Northwest Iowa, talking about the Northwest Research Farm, the drainage water quality work, and the bioreactor work that's ongoing at this location. This is a drone picture of our drainage water quality research facility that was installed in 2013. We have 32 individually subsurface drain plots at this site, starting 4 different nitrogen management practices. This is the Drainage Water Quality Research Facility installation at the Northwest Research Farm from 2013. We see the border tiles are installed, and then in a second you'll see the center tile lines that will ultimately connect to the sumps. Here are the 16 sumps that collect water from the individually subsurface drain plots at the Northwest Research Farm. Within each of these sumps, we have a host of PVC piping to allow us to monitor flow and collect water samples. So drainage from each of the individual plots dumps into one of the sumps, kind of like a garden variety sump like you might see in many households in the basement in Iowa. The water drops into there. It's then pumped out with a sump pump. In line in that PVC is a flow meter so that we can record and capture how much flow is being pumped out of there to calculate how much flow is being drained from that individual plot. And then in line, we have an orifice that the back pressure in the pipe as that water is being pumped out forces a small portion of that water through an orifice so that we can collect that water to analyze for nutrients. And what we would analyze for is nitrogen and phosphorus, specifically nitrate nitrogen and reactive phosphorus. We're collecting a flow proportional water sample. That's important because we want to collect a small portion of all the water that comes out, and we want to collect a little bit more water when there's more water flow. So this allows us to collect a flow weighted or flow proportional water sample. So with that, we can calculate how much nitrogen or phosphorus is coming out our drainage system. So we've been monitoring that since 2015. So we have 5 years of data, 2015, 16, 17, 18, and 19. This is combining the corn phase and the soybean phase, looking at the annual flow weighted nitrate nitrogen concentration for either the corn phase or the soybean phase. Corn or soybean is present every year. Corn and soybean are present every year. 4 plots of corn, 4 plots of soybean for an individual treatment. What we can see is that we see no statistically significant difference in nitrate nitrogen concentration between when we apply that nitrogen in the fall or the spring. The fall and spring is an anhydrous, fall and anhydrous with an inhibitor, nitropyrin. We also have the split application with 45 pounds down as starter and then 90 pounds in season. All those 3 nitrogen application rates, the total nitrogen applied is 135 pounds of nitrogen per acre per year to the corn phase. Okay, so we see when we have that split application, we can reduce the nitrate concentration that we see coming out the tile line. That's good news. One thing also that's important as part of this work is that we see when we apply no nitrogen, we can still see nitrate concentrations in that 8 to 9 parts per million, really illustrating in our high organic matter productive soils in Iowa, with our annual cropping system, we have a leaky system and we still lose nitrate even when we apply no nitrogen. But when we're applying nitrogen, we do see elevated levels of nitrate compared to that no N. But certainly that no N illustrates the need for other practices like we'll be talking about today, whether that be edge of field practices like controlled drainage or bioreactors, or whether that be things like cover crops. One of the newest practices at our research farms, at the Northwest Research Farm, bioreactor, subsurface drainage, denitrification bioreactor. Sometimes we think of it as a fancy name for a wood chip trench. In this case, this is the installation from August 2019. You can see them putting the wood chips into the bioreactor. So what we would do is we would route a portion of the drainage flow through that bioreactor to promote denitrification so that that water going downstream has less nitrate than if that water had not gone through a bioreactor. So this was installed in August 2019. We have some preliminary results from that. The solid circles are the inflow nitrate concentration into the bioreactor. The upside down open triangles are the outflow nitrate concentration exiting the bioreactor. And what we can see is that almost all periods, we have lower nitrate concentrations coming out of the bioreactor than we had going in. We're in the order of 20 to 40% nitrate reduction with this bioreactor. And one of the encouraging things is that a lot of this time when we saw those concentration reductions was in pretty cool periods of the year, in that December through March period. And we're still seeing nitrate reduction, denitrification during those periods. We'd expect maybe lower performance during those periods because cooler temperatures slow down denitrification, but we're still seeing positive impacts of the bioreactor on reducing downstream nitrate export. Really want to acknowledge Heinzen Digging and Tiling for putting in this bioreactor and their help with drainage at the farm, as well as Prinsco in helping with drainage at the farm. Great partnerships among folks to get this bioreactor installed. The next research farm we're going to talk about in results is our Northeast Research Farm, talking about drainage water quality and bioreactor work at this site. So one of the studies I'm going to talk about been ongoing about the last 5 years. We're looking at the timing of liquid swine manure application and how utilizing a cover crop may be important within that liquid swine manure system. So that picture on the left is in April 2016. You might see some kind of streaking in there, areas with larger cover crop. Those are in areas right over that manure injection band. Picture on the left, or right, excuse me, picture on the right shows kind of the height of the cover crop right before termination, before corn planting. So as we look at this corn phase from 2016 through 2019, this is just a subset of the results from the 36 plots at the Northeast Research Farm where we're doing this work. But I think pretty important as we think about coming into fall and thinking about management of manure or nitrogen in the fall. So we had an early fall manure treatment where that liquid swine manure was put down before corn as early as possible after soybean harvest. Then we had an early liquid swine manure, but we had cover crop in that system. And then we had a later manure when soils were 50 degrees and cooling when we injected that manure. What we see in the corn phase is that we see similar nitrate or no statistically significant difference between early fall manure with cover crop or late manure. But that early manure with no cover crop had higher nitrate concentrations than either of the other two treatments. If we look at then the soybean phase, we see lower nitrate concentration where we had cover crop, because this cover crop was grown before corn and before soybeans. We used a winter cereal rye drilled in after harvest of corn or soybeans. So really this work illustrates a couple things. One is cover crops can be very effective for reducing nitrate concentration and loss through our drainage systems. I think that's one reason that's important, is just to reduce downstream nitrate loss. In a year like 2020, like we've seen, we've had drought in some areas. We may have high residual nitrate levels in our soil profile. May be really important to try to get a cover crop there so we reduce the chance of high nitrate concentrations when we do get drainage, maybe in late fall or in the spring of 2021. Also, this really illustrates getting that liquid swine manure on as late as possible, closer to that when soils are 50 degrees and cooling in the fall, can help us reduce nitrate loss from our system. This is the corn yield information on average for 2016, 2017, and 2018. You can see here that early manure and early manure with cover crop yielded about the same on average, but that late fall manure yielded on average about 40 bushels greater for corn yield than either the early manure or early manure with cover crops. So as we think about this, not only did that late manure decrease nitrate concentration compared to the early manure, but we're seeing a pretty dramatic yield benefit on corn from that later fall manure application. So really something to think about, moving that liquid swine manure application as late in the fall as possible can help us both environmentally as well as production-wise here. I understand there are logistical reasons why we may have to put it on earlier, but the more we can look at putting that on a little bit later when those soils are 50 degrees and cooling, there may be some both environmental and crop yield benefit. One of the first bioreactors installed in Iowa was at the Northeast Research Farm, so we've been studying that for a number of years. And the figure on the right illustrates the influent and effluent concentration. If we look at all of those years where we've collected data, that mean influent concentration is about 14 milligrams per liter, and the effluent after the bioreactor is about 7.3. So we're seeing pretty substantial reduction in nitrate in that water that goes through the bioreactor. Now the load reduction is going to be slightly less than this because some of the water bypasses the bioreactor and doesn't go through, as well as we may have more flow during periods when we don't have quite as much nitrate concentration, but still we're seeing dramatic benefits of bioreactors in reducing downstream nitrate loss. And this bioreactor was installed with help from a local watershed group, Coldwater Palmer Watershed Association there. So again, a great opportunity to partner between some various entities and our research and demonstration farms. Now, drainage management and wetland work down at the Southeast Research Farm near Crawfordsville. In 2007, on 30 acres, we installed a drainage water management research facility, and that water from that drainage water management site drains down into a wetland, about a 0.3 acre wetland, about 1% of that drainage water management area, or the drained area of the drainage water management area. So since 2007, we've been monitoring the results down at this site. We have 3 different drainage treatments in that drainage water management area. We have a conventional drainage, 60-foot spacing, 4-foot drain depth. So 4-foot drain depth, 60-foot spacing, conventional drainage. Controlled drainage, 4-foot drain depth, 60-foot spacing with our outlet control structures there to manage the water table back in the field, and then a shallower drain placement, 2.5-foot drain depth, 40-foot spacing. What we've seen on an annual, kind of an average annual basis, we see about 25 pounds per acre of nitrate loss from our conventional drainage system, but about 12 to 15 from our controlled or shallow drainage system. So with that controlled or shallow drainage system, we're able to reduce downstream nitrate loss about 40 to 50%, at least direct nitrate loss out of the drainage system. If we looked at corn and soybean yield, what we see is similar corn and soybean yield between conventional, controlled, and shallow drainage, but we do see a yield benefit of those compared to undrained. About 5 bushel per acre in soybean and about 8 bushel per acre in corn. I think those are on the conservative side of what we'd expect in a field setting for 2 main reasons. One is that undrained area. While there's 6-acre blocks, there's still some lateral effect of adjacent drainage, so they're not truly undrained. The second reason is that we plant these all at the same time. So we plant them pretty much when the undrained is fit. So we're not getting some of those benefits of early planting that we might get from our drainage treatments. So again, we see some drainage benefit, but maybe not as much as we might see in some field settings because of that timing of planting as well as not being truly undrained. We also have that 0.3 acre wetland there that we've been monitoring since late 2017. If we look at all of those years, we've seen about 7,100 pounds of nitrate nitrogen entering that wetland and about 4,900 pounds of nitrate as nitrogen in the outflow, with about 2,200 pounds of nitrate as nitrogen removed by the wetland. We calculate that by measuring the inflow. So you see the V-notch weir in the upper right. That's how we would measure inflow to the wetland. Then we collect samples of inflow and outflow water to compute that inflow and outflow of nitrate as nitrogen, and then what was removed by the wetland. You can see a picture of the wetland down there, a lot of cattails in there. We'll say this wetland does go dry in very dry years since it's collecting drainage from a fairly small area. Next, our prairie strip sites. Those are located at the Armstrong Research Farm and the McNay Research Farm. I'm going to talk specifically about the results at the Armstrong Research Farm. So this is a picture of one of the prairie strip sites that we have, and this is the one at the Armstrong Farm. Those semicircles that you see in the foreground are the prairie strips. All that water drains to a common point, and we monitor the water coming off that field where we have prairie strips. We have a control field with no prairie strips about a mile away, similar soils, similar slope, and similar management as the field with prairie strips. So we have a pretty good comparison of fields control without prairie strips and a treatment field with prairie strips. So as we look at the data from 2016 through 2019, during our monitoring period, which is during the non-freezing period, cumulative, we had about 107 inches of rain. Overall, we've not had a lot of runoff from these sites, so they haven't been particularly wet, or the Armstrong site in particular, but we have seen a reduction in runoff where we have the prairie strips. Our treatment is lower in cumulative runoff over that 2016 to 2019 period. Also, while both fields are low, we see lower sediment loss from that field where we have the prairie strips, a treatment site. So illustrating the benefits that we can get from prairie strips. The picture there on the lower left is our H flume. And so what we do with that is we monitor the depth of water flow going through that H flume. And then based on that, we have an auto sampler in that box there. And based on how much flow is going by, we will sample a portion of that water based on kind of the flow volume that's gone by. Okay, so it's not a time-based, it's a flow-based sampling, event sampling, since we only have water flowing there during runoff events. So these prairie strips can definitely help us with water quality, but they can also provide other benefits on the landscape, such as pollinator habitat, wildlife habitat, maybe some aesthetic value out there as well. So I'd encourage you, if you want to find a little bit more out about the water quality research being done across Iowa, specifically at some of our ISU research and demonstration farms, I'd encourage you to go to the Iowa Nutrient Research Center website, and we have a water quality research map there. You can look at various categories and see where research is being done on those throughout the state, having work in categories of edge of field, land management, multi-objective, and nutrient management. So I'd encourage you to go in, look at some of the work that's being done. You'll find some pictures, some results, some publications, as well as contact information if you want more information about those specific projects. But hopefully you can see that research is being done throughout the state of Iowa. And in particular, our ISU research and demonstration farms are very well represented on our water quality research map. None of this work would be possible without the support from many folks. In particular, our ISU research and demonstration farms. The staff at those farms have made this work possible, have brought topics to us, and have made sure that quality data is collected. We also have financial support from a number of different entities on these various projects. At the Northwest Research Farm, we have support from the 4R Research Fund and the Foundation for Food and Ag Research for that drainage water quality work. As I said, Heinzen Digging and Tiling and Prinsco were instrumental in getting the bioreactor installed. At the Northeast Research Farm, on that drainage water quality work that I summarized there, specifically we had support from the Iowa Pork Producers Association and Calcium Products and the Iowa Nutrient Research Center. At the Southeast Research Farm, on that drainage water management and wetlands work, we've had support from the USDA National Institute for Food and Ag, specifically our Sustainable Corn Project, and then we had a USDA NRCS Conservation Innovation Grant that made installing that drainage site possible. And the Prairie strips, funders too numerous to mention, but specifically on the water quality side, we've had some support from USDA Farm Service Agency, ISU, FFAR, Iowa Nutrient Research Center that have made that water quality work possible, and many more. So I thank you very much for your time today, and hopefully we can have some lively Q&A during the Q&A session. Feel free to get in touch with me. My contact information is there. Feel free to get in touch with me at any time. Happy to answer questions and have additional dialogue about the importance of water quality research and the work that's being done by ISU researchers in these areas.
Thank you, Matt. Welcome to the Q&A part of the day. We'll have live questions answered on live with Dr. Matt Helmers. This is stop 2 of our virtual tour today, and Matt's having mic problems, so he's going to be talking to us on the phone, even though we're going to see him through the other system. A couple reminders for you. If you have questions for Matt, please put them in the Q&A box at the bottom of your screen. I saw a couple in the chat box we'll get to also, but please put them in the Q&A box. They're easier to find. If you're a certified crop advisor, hopefully you should be getting credit today if you put your CCA number on your registration form. If not, please put that in the chat box and we'll make sure you get credit for today's session. A reminder of tomorrow's program. Tomorrow's program is Dr. Allison Robertson. She's going to be talking about her cardinal corn fungicide trials, her annual work on corn fungicides. We start at 8 o'clock in the morning. It's a great summary of multi-year work. So join us again tomorrow. And one added to the list on Wednesday, September 2 from 1 p.m. to 2 p.m. as an outcome of the derecho issue. We're going to be offering a webinar called Managing Down Corn, including some video that was put together last week of actually destroying some of that zeroed out corn in that process. So those are some upcoming things for you to be aware of. But now we're going to get to the questions. Matt's ready to go. I can just see he's just ready to go. So let's start with this one. This one says, with the drought conditions in most of Iowa now, hopefully not long-term, do you expect results showing much higher N concentrations in your present 8 to 9 in the future?
Yeah, that's a good question. And actually, we're working on a short article about that, of what we've seen in the past. So, you know, we fortunately, with some of this long-term data that we have at Nashua, where I am right now at the Northeast Iowa Research Farm, and then at our Gilmore City site near Gilmore City, Iowa, we had data on 2013. Well, we had long-term data, but we had data following the drought of 2012, and we did see an increase in nitrate concentrations at most of those sites in the spring of 2013 when we ultimately got rainfall and drainage. So we saw those at those sites going from, you know, maybe 12 all the way up to about 20 parts per million in that spring of 2013. But one of the things is that where we had a cover crop, we were able to mitigate some of that increase in nitrate concentration. So I think it really illustrates the importance of thinking about that, about something like cover crops this fall. Certainly understanding right now we don't have the moisture to get those germinated, but if we get some rain, can be thinking about how we might start those. I think it could be, an effective strategy to mitigate some of that risk that's likely to happen when we get subsequent precipitation. One of the other things that I didn't mention in the presentation, but would like to, is that these ISU research and demonstration farms are a great site to do this water quality research. But I really want to acknowledge the farm associations that in many cases, in almost all cases, have been very instrumental in encouraging this research to be done, for those farm associations to get the land so that we can do that research. And so, those boards have been very important and supportive of the work over the years and have been very instrumental in getting that on there. I know, I've been at Iowa State now 17 years, and one of the first trips I took was to Northwest Iowa, to the new farm they had bought, and they said, we want water quality research being done here. And so that's really led to that work. And so the work of the associations and the farmer-led boards have been so instrumental in the work that we've been able to do. And I'm a little biased, but I think Iowa State University has been a leader in this area.
I would agree, Matt. I know the Northwest Research Farm Board 20 years ago was talking about doing water quality because they could see what the future held in store for us. And I'm not sure us as staff had the foresight that our board did. So I'll encourage people to get involved with with their local research farm associations. We need your input, and I think that's a great thing. Okay, most of the rest of there's an exception or two, but most of the rest of the questions are asking about bioreactors. People are curious about bioreactors, Matt. The first one is, how did phosphorus loss change with the tile water through a bioreactor?
Yep, that's a good question. Really, we look at the wood chip bioreactors as a nitrate mitigation strategy. There's been some work done. My colleague, Dr. Michelle Sapir in our Ag and Biosystems Engineering department has done some work looking at phosphorus. And really, we can't consistently see a reduction in phosphorus levels of that water going through the bioreactor. Now, having said that, there's some active work looking at, can we put some other media, at the beginning of the bioreactor or the exit of the bioreactor, maybe iron filing, something like that, to potentially reduce that phosphorus level. So it's probably going to be something different than wood chips, but there may be another media. In fact, we have some work that recently funded by the Iowa Nutrient Research Center that would be start looking at some of that, even from some of our pothole systems, where we might be able to run that water through some type of filter medium, absorb that phosphorus, and reduce the phosphorus, especially the dissolved phosphorus that may be coming out in that water. So can't rely on the wood chip bioreactors to reduce phosphorus levels.
Terrific. Thanks, Matt. More bioreactor questions. I'll make you a list. Cost.
Okay.
Lifespan. What do you put over the top of them once you're done? If you put something over the top, can you utilize some of the nitrate that's in the wood chips that comes with it? I think those are 4 of the questions that I'll put together in one.
Okay, great questions. So the cost of the bioreactor first might be on the order of $12,000 to $15,000 all told. Those are some of the numbers I've seen. It's going to depend on a few things. One is kind of the availability of the wood chips and what you might have to pay for those. So those could be a third to half of the cost of the bioreactor. And so, we need quite a few wood chips. We're talking a couple semi-loads at least of wood chips. And so that's where, a big cost could be. Now, there are state and federal programs to help with that through NRCS and the Iowa Department of Agriculture and Land Stewardship. But that's kind of the rough cost that would not necessarily be the direct cost to an individual producer because of those other programs. Okay, how long do they last? That is a great question, and one folks are doing active research on. And one of the first bioreactors put in Greene County, Iowa, and that was dug up about 2 years ago. It was in place about 8 to 10 years, and they noticed that the performance was starting to go down. The nitrate reduction was starting to be reduced. So they had to dig it up. Now that bioreactor did have some wood chips that were more almost mulchy, not clean wood chips. And so I think, that might have reduced the life expectancy of that. So we might think in that 10 to 15 years that we're probably going to have to go in and replace those wood chips. Now we think they should be able to just be lightly land applied. They shouldn't be, have any heavy metals in them or anything like that that would preclude them being put on the land. But we'd want to put them on, very lightly, I guess, on that land. So that's kind of the life expectancy that we might expect for that. And we are looking, again, some research funded by the Nutrient Research Center is looking at the potential for corn cobs, because really with the wood chips, what we're relying on is carbon to help with the denitrification. And so corn cobs could be a good source of carbon. Their life expectancy might be less, but at least when they're good, they might even have greater denitrification. So trying to look at some other media that we might be able to use as well in those bioreactors. Okay, can you plant over the top of them? I would not run heavy equipment over those. And so generally we're probably putting grass or in some cases maybe some pollinator habitat over that small area. So, there's a lot of wood chips, but the footprint area is still pretty small. We're talking about 20, 30 feet wide, maybe 100 foot long. But I would not run heavy equipment over those because, I think you might consolidate or compact those wood chips and reduce some of the flow properties through there. Okay. So one of the things is that really couldn't utilize the nitrogen that's removed with the bioreactor, because what's happening is that we're denitrifying that. And so we're converting that nitrate primarily to dinitrogen gas. So it's not becoming a sink for nitrogen, but it's actually, we have a process that denitrification that we're converting that nitrate into primarily dinitrogen gas. So that's going off back into our atmosphere. So wouldn't be able to utilize the nitrogen that's removed from that bioreactor. That's similar to how the wetlands are functioning in removing nitrate. It's also similar to how saturated buffers that many of you might have heard about, how that's primarily removing nitrate. There may be a little plant uptake in those systems too, but a lot would be due to denitrification.
Great questions. We have more questions. We do promise to be done in a half hour, and we're 2 minutes over. So for those of you that have to leave at this stage, that's wonderful. Thank you for joining us. We hope to see you in the morning. We'll wrap up more later, but we're going to continue with questions. So if you're still interested, we're going to let Matt answer questions, and there seem to be quite a few of them yet. There is a question here of, can we store some of the excess water from spring rains and apply it back in July, August when moisture is short?
Yes, I think there's the potential for that. In fact, we are starting work at Iowa State University in that area, and we're part of working with colleagues around the North Central region to look at this under a practice we would call drainage water recycling, where we are capturing that drainage water and using that for supplemental irrigation during the crop season. So what I would say, I'm an engineer, so we can engineer that system. The question is, how big does the storage reservoir need to be? What's the cost effectiveness of that? And so that's what we're looking at now. I have a graduate student that's using some data from a farm near Story City where they've done that, and we're trying to parameterize a model, AppSim, working with Soterius Arcantulus to look at what some of the long-term impacts might be on crop production, which then can help us evaluate the cost effectiveness of this practice. You can find a little more information about that overall concept through the Transforming Drainage project. So I think it's transformingdrainage.org, and they actually have a model, Edward. Don't ask me the acronym for Edward, but that would help with kind of thinking about the sizing of the pond and so forth. And we've been able to use some of the data from our Southeast Research Farm to help parameterize that Edward model and look at the potential impacts of drainage water recycling. I'll just add quickly, I'm getting too wordy, I know, I apologize for that. There would also be a downstream water quality benefit associated with this practice, because instead of that water leaving the field, we're storing it and using it for crop production. And so that nitrate that would have gone downstream, we're putting back into the field, and hopefully then, increasing plant water use of that crop field.
Would holding that water also help denitrify some of the nitrogen in it in the process?
That's right. While it's sitting in the pond, we're looking at that. That's exactly right. We may see some denitrification, so kind of additional benefits of that practice.
Terrific. Next question. Is there any work on saturated riparian buffers going on at research farms? Could you say anything about SRBs and their benefits? I'll also note that the Northwest area, we are working with Dordt University. They have a saturated riparian buffer also, and we've worked with them with projects also. Yep.
And yes, we do. There is saturated buffer work going on ISU research farms and some of the ISU farms around Ames. So, as I said, they function in many ways similar to a bioreactor. We're diverting a portion of that tile water to try to go through the shallow subsurface below that buffer zone. And so we're primarily getting denitrification using the carbon in the soil, in that case, to promote denitrification of that system. So yes, and so I would encourage folks, you can go to our water quality research map on the Iowa Nutrient Research Center website, and there'll be some sites indicated there where we're doing saturated buffer work.
Related to that, are you doing any work on oxbows and on utilizing old oxbows?
Yeah, that's a great question. All this prompting these on work that's being funded by INRC. And so that work really not being led by Iowa State University, but Keith Schilling at the University of Iowa, actually the state geologist, and with IIHR Hydroscience and Engineering, has been working with many partners, the Nature Conservancy and Iowa Soybean Association, to monitor the water quality or nitrate reduction benefits of multi-purpose oxbows. So there can be a lot of oxbow restorations for habitat, for a host of other positive benefits. But one of the things from a nitrate reduction standpoint is those oxbows have to see the nitrate. And so that's why we might say multi-purpose oxbows. So we need to get that tile water into those oxbows. But then when we do, they can be very effective for nitrate reduction. And so, yeah, there's research work going on in Iowa on those practices. And I think just another example of leadership by folks in Iowa to kind of look at different ways of thinking about ways we can integrate these kind of, in a sense, small water storage features on the land to promote denitrification.
Thanks, Matt. Couple more questions left if you're still willing to hang in there.
You bet. Absolutely.
First, a comment from Keith. Thanks for your comment about having plenty of wood chips around Cedar Rapids right now. Unfortunately, I know you probably do. So we feel for those people. Of course, all you can do is react to this stage, but we do feel for you because that's been a disaster. How many acres will a 30 by 100 bioreactor handle?
Somewhere in the 50 to 100 acre type scale. That these are kind of a field scale practice. So we're talking about that kind of 50 to 100 acres. Now, are looking at kind of some dual chamber type bioreactors that may be able to handle more. So, there's been some work looking at that where we might put them in parallel or maybe even in series to get larger acreage for those bioreactors.
Terrific, thank you. One last question. I don't know if you want to handle this one or you want to refer it to John Sawyer. Hold on, it moved on my line. Now I got to go find it again.
I think I see it. I see it
Do you think
in the chat box.
Like nitropyrin instinct with early fall manure reduce nitrate loss? Why or why not?
Yeah, I think with that early fall manure, I don't think because some of that is going on when those soils are so warm that we're probably not going to get a lot of benefit from that instinct. In that case, we have done a little bit of work here at the Northeast Research Farm with later fall manure with and without instinct. Even in that case, we really didn't see any nitrate reduction benefit or substantial nitrate reduction benefit with that. So we late fall manure and a continuous corn with and without instinct. We really didn't see any nitrate reduction benefit. We did see a little bit of yield benefit, corn yield benefit of that instinct, but not that water quality benefit that we might expect. So I think the use of instinct can be beneficial in some cases, but it might be a little more hit or miss with if we get the water quality benefit year in and year out.
One last quick question: what kind of wood chips in a bioreactor?
That's a great question. And again, I hate to say there's research going on that, but there still is research. In fact, Billy Beck, that is our new forestry extension person, is doing some work on that specifically, looking at some different tree species. But really, in general, we found almost all tree species can function pretty well for nitrate reduction. And probably a couple things, if we look at the practice standard for bioreactors, is maybe not oaks, because there might be a lot of tannins in there that could be released. And the other is, and there's been some work in Australia that they still found benefits with cedar, but cedar might have some antimicrobial properties that reduce some of the effectiveness of that. But a lot of our hardwoods or softwoods can work fairly well. I think one of the big things is we want to have pretty clean wood chips. So that's one of the challenges with some of the down trees we have right now. We have a lot of leaves in there. So there may be a lot, if we were to use those, there may be a lot of organic leaching of that, and that's probably not something we want. So we want fairly clean wood chips, not kind of fibrous or mulchy type material.
Matt, you demonstrated why I enjoy working with you so much. You've answered questions well. I liked your presentations, and it looks like our audience has hung with us through a bunch of questions and going 15 minutes over. So we appreciate that very much. Thanks for being with us today, Matt.
Absolutely, my pleasure.
Yeah, and to the audience, thanks for joining us today. Big thanks to all those behind the scenes that really helped us out today. I've enjoyed having you here, and I'm still looking forward to seeing you face-to-face at Research Farm sometime in the future. I like the personal connection better, but in the meantime, I'm glad you're here, and hopefully you're learning. Don't forget to tune in for tomorrow. Allison Robertson will be on at 8 o'clock to talk about our cardinal fungicide trials. Always great information. Thank you for being here today, and have a great day. Thanks for joining us.